Today we are going to learn about the rules of exponents. The first rule we are going to talk about is the power of 1. This means any number to the power of 1 is equal to itself. It is more clearly seen in these examples. So the number 5 to the power of 1 is 5. The number 6,174 to the power of 1 is 6,174. And the variable b to the power of 1 is just b. The zero property basically says that any number to the power of 0 is equal to 1. This means that 5 to the 0 power is 1, 6,174 to the power of 0 is 1, and the variable b to the power of 0 is also 1. The multiplication property of exponents. When you multiply two numbers with the same base, you can add the exponents together. If we were to write 4 cubed times 4 squared out in expanded form, we would have 4 times 4 times 4, which is our 4 cubed, and we would have 4 times 4, which is our 4 squared. Now, if we add up all of the 4s, we would have a total of 5, which is how we get 4 to the power of 5. If we did not want to write it out in expanded form, we could simply add 3 plus 2 together and get 5, and so our answer would be 4 to the 5th power. Another example of this could be done with exponents. We have x to the 5th power times x. If we expand it out, we get x times x times x times x times x 5 times, and we multiply it by another x. If we add up all of the x's together, we will get x to the 6th power, or 5 plus 1 is equal to 6. Here are two practice problems. If I wanted to write the first one out in expanded form, I would have 2 times r times r times r times r. That's r to the 4th power, and I would multiply it by r times r times r times r. If I add up all of the r's together, I get 2 times r to the 8th power. The easier way of solving this problem is to simply add 4 plus 4 together, and we would get 8. The second example of the multiplication property of exponents is a little bit more complicated. We have 2 times x to the 4th, y to the 3rd, all times y to the 3rd. If we do not want to write this out in expanded form, we could simply use our rule to add the exponents together. In this case, we only have one coefficient, and that's the number 2, so it will stay the same. We have x to the 4th, and there's no other x in the expression, so we're just going to leave x to the 4th as is. And we have y to the 3rd times y to the 3rd. If we add 3 plus 3 together, we will get a y to the 6th. It's that simple. Next, we have the power property of exponents. And this means when you raise a base to a power and then raise it to another power, then you can multiply the exponents together. In our first example, we have 4 to the 3rd power all raised to the 2nd power. This means everything inside of the parenthesis is being raised to the 2nd power. So if we were to write this in expanded form, it becomes 4 cubed times 4 cubed. If we were to expand this out even more, we would have 4 times 4 times 4 times 4 times 4 times 4. If we add up all of the 4's together, we get 4 to the 6th power. The simpler way to do it is just multiply the exponents together, and we get 3 times 2, which will also give us 6. In our second example, we're raising x to the 4th to the 5th power. In expanded form, we would get x to the 4th times 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 x to the 4th. If we add up all of the x's together, we would get x to the 20th. So essentially, the power property is just an extension of the multiplication property. Some examples here. We know 4 times 2 is 8, so this expression will simply be 4 to the 8th power. This is because it would be 4 to the 4th times 4 to the 4th. If you add 4 together twice, you would get 8. Now this second example is a little tricky. There are multiple variables and coefficients that are all being raised to the 4th power. This means if we were to write it out in expanded form, it would be 2 to the 4th power times y to the 4th power times x to the 16th power. It would be x to the 16th power because 4 times 4 is 16. It's important that we remember this property. And this is the expression in simplest form. If you want to multiply out the coefficient right here, you could. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. So our answer would be 16 y to the 4th x to the 16th. The division property of exponents says when you divide two numbers with the same base, then you can subtract the exponents. So in my example here, 8 to the 6th power divided by 8 to the 3rd power, we would get 8 to the 3rd power because 6 minus 3 is equal to 3. If we wanted to write it out in expanded form, 8 to the 6th power will give us 8 times 8 times 8 times 8 times 8 times 8 divided by 8 to the 3rd power, which is 8 times 8 times 8. Now, the same way we simplify fractions by dividing the same number into the numerator and denominator of a fraction, we can reduce this expression. 8 divided by 8 cancels out to be 1. 8 divided by 8 cancels out to be 1. And 8 divided by 8 cancels out to be 1. We are left with 8 3 times, or 8 to the 3rd power. In the second example with variables, we have n to the 4th divided by n to the 1st power. 4 minus 1 is 3, so we know our answer is going to be n to the 3rd power. Or if we wanted to write it in expanded form, we could simply cross out an n on top and an n on bottom. So here's some more practice. Let's write this one out in expanded form. We have 4m times m divided by 2 times m times m times m. Now we can simplify. We can cross out an m in top and bottom, an m in top and bottom, and we can divide 4 by 2. When we divide 4 by 2, we get 2, and there's no more m's on top, but there is an m on bottom, so we can put the m on bottom. In the second problem, before we can use the division property, we first have to use the power property of exponents. This becomes n to the 3 times 4 is equal to 12 times 2 to the 4th times n to the 12th. Again, we have 3 times 4 divided by n. To simplify the numerator, we have 2 to the 4th, or as we previously figured out, 16, n to the, since we're multiplying our n to the 12th power times n to the 12th power, we get n to the 24th, and we would divide that by 9, or by n, I'm sorry. Now we can use the division property of exponents to subtract 24 minus 1, and we know our answer will be 16 times n to the 23rd. The final exponent rule is about negative exponents. Mathematicians do not like negative exponents and always rewrite answers so that the exponents are positive. Here is how. if we have 8 to the negative 1, we can move it to the bottom or the denominator of a fraction by making it positive. So essentially, if it's a negative exponent in the numerator, you move it to the denominator. And if it's a negative exponent in the denominator, you can move it to the numerator. In the second example, we have 1 divided by b to the negative 4. This means it's b to the 4th power in the numerator over 1, which will just be b to the 4th power. Here's 2 different examples. In the first one, we have 3 to a positive 1 exponent, so we'll leave that in the numerator. Leave n to the negative 4. Since 4 is negative, we're going to put n to the 4th in the denominator. Then we're multiplying it by 4, which has a positive 1 exponent, so we'll put that on top. And n to the negative 3, so we'll move that to the denominator by making it a positive exponent. And then we'll multiply it by 2n. Both of those have positive 1 exponents, so they'll stay in the numerator. Now we just multiply 3 times 4 times 2, and we get 24n divided by n to the 4th times n to the 3rd means we add 4 and 3 together, and we get n to the 7th. And now we can use the division property to cancel out our n. And this becomes 24 divided by n to the 6th power. In our final example, v is to the negative 3 power, so that would go to the denominator. 2v to the 4th would stay in the denominator, and 2v to the 3rd would move to the numerator. If we were to simplify this out, we would get 2v to the 3rd in the numerator and 2v to the 7th in the denominator. When we simplify this, we can cancel out 2 and 2 and subtract 3 from 7, and our answer would be 1 over v to the 4th power. And these are your rules of exponents.